Hello and welcome. In this video or project, I plan on making myself a small little digging machine. Now, what do I mean by that? I mean what Harbor Freight would call their towable backhoe. I want to make something similar to this, which brings us to this thing, the Springer, or Elgo Plus, or Springer Max, whatever you want to call it. This is sold a company out of Sweden. They will ship it to you. I don't know what it costs. I think it's about $10,000 plus shipping duties. I don't know, 15, 16,000 to get this one. However, I don't think that the Swedish are actually making this. I'm pretty sure they're just importing it from China, painting it, and making it look a little better, because you see these things in Alibaba for, $2 to $5 grand. So to duplicate this chassis, basically, I'm looking at thousands and thousands of dollars. And I don't believe that this little machine is going to be worth thousands and thousands of dollars. Yeah, this exact one, this good looking, running and going, a couple of grand, no problem. But am I going to put a couple of grand into making the base? No, not going to happen. I mean a few thousand into the base. So what I plan on doing with my little machine building I want to do is a slewing of the top machine combined with the self-moving feet of our towable backhoe, and do something like that. That eliminates the hydraulics down to the bottom. Should allow me to slew and move itself around mostly, and save a lot of money on getting that track system set up. So I was able to find a cheap slew bearing, a small little guy, a little too small probably, on eBay. This was, I paid $50 for it. Looks like some moron tried to tap a screw hole into it and broke it. It is a new, never used, slightly one-hole damaged slew bearing. I think it's a little too small, but according to the manufacturer's specs, it is more than capable of handling the side loads that it needs for my little machine here. I have this 5/8 piece of flat steel. My plan is to put some legs on it, similar to our towable backhoe. Center mount the bearing, where the body of my machine will then bolt to the top of the bearing. For actual rotating, I have a ring gear that I pulled off of a early 70s Evinrude, unbolted it from the flywheel. The plan is to bolt this down to my steel plate, attach a gear to it, and get it to turn. Problem is, I cannot for the life of me figure out that gear profile to buy myself a pinion gear for it. So, plan then became, take the pinion bearing off of the starter. This is almost an inch. So what I wanted to do was drill a 1-inch hole through there, weld the inner collar here to the gear. So we're going to have a 1-inch hole through there, weld this, and then use an inner key broach to broach a keyway into there to go onto a hydraulic motor, which will mount this there and give me my slewing ability. The problem is this is high quality steel. It's hardened too. So you're going to break a drill bit long before you ever get a hole through this thing, yet alone a key broach. And even welding, it's going to be a little questionable at best. So the pinion's out, can't figure out the gear profile. I'm screwed on this whole plan. So that goes. So since I'm not going to spend the money on an external tooth slew bearing, can't weld or modify that pinion, plan C is to use a gear and chain method. My plan now is to make myself a wooden version of this gear, clamp it down with an inner hole, plasma cut out a hole big enough for this bearing to fit into, and then drill some holes, 8 of them actually. So this will get cut off. We'll have a huge hole in the middle and mounting holes externally, where I will mount that, followed by my gear. My hydraulic motor will sit over here with a gear, and I'll have a chain driving the whole thing. That's the plan to do for slewing. And that's where I am so far. I got this kind of trimmed. I don't have any real way to cut a plate that big, so angle grindered that one. That was fun. And as I'm standing here, I'm wondering how square I have it. It should be pretty square. Yeah, it's close enough. So anyway, that's where I am right now, building the base. Let me show you the legs I have so far. Well, first of all, I needed to upgrade my workstation or my metalworking abilities for a little while. So I rigged myself up a welding table. It's just 1/4-inch steel, but with the with my little 2x4 desk and enough shims, we're good and flat, which is all that really matters here. I picked up a lot of soapstone markers, a bunch of these little magnetic angles, a bunch of angle grinder wheels, and a whole bunch of other metalworking supplies for this. Paul gave me a $100 Home Depot gift card for Christmas. Thank you, Paul. That's where all these tools came from, as well as a new blade for my metal cutoff saw. So, a lot of upgrades here to make this thing. So this is one of the legs that I have made up so far. I got 2. The other one is right here, as you can see. Doesn't come to the floor in the back because that is where these wheels will bolt in, just like so. These are off of a tow truck dolly. I found these on the front of my property at my old place, which is right along the highway. They fell off a tow truck. I ran an ad in the paper and on Craigslist at the time saying, hey, I found this part off a tow truck. If you lost it, let me know. Just give it back to them. I think I ran the recycler ad for a little while. I think they were free for a month at a time or something. But Craigslist ad, it was up there for like 6 months. And so I don't know where these came from, but that's what they are. I tried to return them to the original owner and couldn't find them, so they are mine now. They're pretty nice, I think. Anywho, I started cutting out all of the tow truck dolly stuff, and I basically have this plate, a little over 3-inch shaft with a little collar that I'm going to cut off. I'm going to drill a 1-inch hole through there, and this will then run through the leg. So, pretty basic. I'm then going to have 2 supports running down the center here to kind of make them square. And yeah, that's the plan for the leg basically. Also, if my slewing and rotating on the machine in general doesn't work, I can then reuse the legs to make plan B of this machine. Let's hope we don't have to come to that, but I'm future-proofing myself here. This whole project, everything I'm going to be doing here, isn't really something that a home workshop with a welder and an angle grinder and a drill can easily accomplish. Mainly the booms and, well, where I'm attaching the wheels. All of your holes need to align, and that's going to be a problem with basically hand tools. Like the boom, for instance. If the boom and the hydraulics, if those holes are off and your boom is going this way and your hydraulic is going that way, you're going to have problems. Plan to overcome this is to build this jig, which will have 2 1/4-inch starting holes on it. I will slip it over the square tubing and use those little holes as my guides. They should align perfectly and hope for the best, I guess, is what I'm going to be doing. So let this cut out, glue it up, and see what happens. Oh, so that hole in the center is exactly centered on this 3-inch square. If that makes any sense. Okay, got my drill jig all gluing up, so we just let it dry and hope it works. Well, here it is, done and glued together. So it just slips over and shows you the center. I tried to pre-drill a hole, and you can see it's just a pinch off. So I'm going to go in there sideways, correct it, and drill a hole straight through and see how it looks. Alright, so there's the rough start of my hole. Yeah, that is spot on. Let's turn it over, see if the back can be equal. Yeah, this is going to look great. Drill jigs, who'd have thunk it? Alright, holes are through both sides. 1-inch leftover stock of something. Not bad, not bad. That hole saw doesn't exactly make perfectly round holes, but that's fine. Well, putting my magnet square on it, that thing is square. Oopsie. Yeah, so hopefully you can see what I'm looking at. That's the squarest of squareness that I've ever squared. I mean, that is good. I'm happy with that. If they all come out as straight as that just did, I'm going to be styling. This thing will work fine. All right, got the little, I don't know what you call it, axle hub attached to the leg here. I just wanted to show you how I did it. I don't have much to work with on these little things, so this was the best thing I could come up with. I had another 1/8 inch little plate of metal in behind here just for additional support. Welded it on, bolted together, and that's kind of how I'm doing the wheel hub. And you can see here what I originally have. I'd like a piece of metal welded on both sides, you know, additional support, but it's just you don't have the room here. So basically what I'm doing is cutting this off, cutting the back off, because they did a great job welding that together. Drilling a hole in the leg, as you can see here, another hole for the bolts they got here, and attaching it. So pretty straightforward. Also, I don't know how long this thing was sitting in the bushes before I found it, but the bearings, this one's not as bad as the other side. The bearings kind of suck, so I've got to fix the bearings. That's no big deal. I ordered 2 bearing sets for this little hub. Pretty grateful I did, because I knew one set was all rusty because that's the first one I installed, and I didn't take off the other hub yet. But this is the outer, inner. You can see there, time to go. There it is. So you can see here on the second hub that it needed bearings too. So glad I ordered 2 sets. That way it don't get held up too long. I should replace the race, but I'm not going to, just because I don't have a little driver to drive it in. And I don't feel like going through the hassle of extracting the old one. So you understand. All right, hubs are on. It isn't necessarily heavy, like one person can move it, but getting it off, not that easy. Like, I don't know, it probably weighs 120 pounds, I'd guess. So not light, but it's not something you want to pick up, you know. Anyway, we are a 1/4 inch off from being nice and level. So if I add larger plates on each feet, the base will be perfectly level. Which, given my shop setup, you know, basically an angle grinder and a saw, that's pretty good, being, you know, only 1/4 inch down. Lengthwise, we're fine. Angles, they were all cut at the same time. They're all fine. Dimensions from the, you know, legs to the back, we're good there. Everything is spot on, except on a 1/4 inch downhill. But I'm fine with that. So this is where things are going to start getting kind of crucial. The measurements, hole spacings, and placements of all of the items to make this thing, you know, rotate or slew, they're all pretty crucial. If any of them are off, I think when it turns or goes to rotate and the gear is out of alignment from the actual center bearing, it's going to overly stretch the chain and something is going to break. I don't think it would be the chain. It would probably be the hydraulic motor, the little shaft that turns it. I think it would probably get bent or oblonged or just ruin the seal, and there goes the hydraulic motor. With any luck, the chain would break, but I don't know. A lot of those motors aren't made for a side load, so I don't think so. I think the motor would probably deform. So what I'm doing here is cutting out a template of a gear I plan on using, which I then need to modify to be able to hold the center bearing. It's going to have a 3.8 inch bolt circle on it, which is what it's cutting out right now, and that'll give me little alignment holes, if you will, or placement holes of where it should go. This will be one of 2 stencils I need to cut out. This one is just to modify the gear. The next one will be for the gear mounting and placement. if that makes sense. So yeah, just let this thing cut out and I'll show you the plan. Alright, I got my Viver little plasma cutter hooked up here. Got it bumped up, both the air and the wattage as high as it'll go. Airline's leaking a little bit. Need a new fitting, but that's alright. So yeah, I pretty much got one chance at this. This really is where a lathe would come in handy, you know? Although, who wants to do everything with the proper tools and equipment? Then you can just use whatever. Alright. Let's see how this goes. Wish me luck. What do you think the return policy on Amazon is, as far as when you cut a 6-inch hole out of the part? You think they'd still take it back? Nah, I'm just kidding. That actually worked out pretty well. Obviously, it's not a pretty cut. Free handing isn't something I'm good at, but the bearing fits in the middle. Enough room for the future Zerk fittings I wish it came with. So that should be fine. It's burning hot right now. I'll let it naturally cool down and start drilling some holes in it. While that happens, I'll explain what this plate is. This is where the bearing will melt, as well as that outer gear, and this will have a series of bolts along the perimeter, bolting it down. And that's pretty much it. This is 5/8 plate. That's the last of it I got. I squared it up, the best I could with the old angle grinder. Came out okay. Obviously, got to clean it up, but yeah, that's the plan. Drill 12 holes in this thing to bolt it down, and then drill 8 more holes for the bearing, and then 8 more holes for the gear, and we'll be good. So a couple of holes to drill on this little plate. Well, I got all the holes drilled. It's kind of a pain. Well, my dad, he has a pretty big drill press, so whenever I need to use it, I go over there. So I got the metal and my gear, and I hawked over to his place and started drilling the hole. And it's got a pretty big base on it, but I still had to hold the plate up when I had to do the corners. That wasn't fun because this thing's not exactly light. Anywho, so I got the holes drilled. Got these two in to hold it for me and to go drill the rest of the holes. Drop some screws in it as I go, just to make sure it stays lined. Flip the whole thing over and drill holes on the back to get a nut onto those screws. That's not going to be fun flipping it over, but I'll figure it out. All right, this is going to be the drill guide for the bearing and the outer gear. If you notice, I have a 1/4 inch hole in the center, right there, which will go into that center hole right there and should keep everything nice and straight for me. You know what's silly expensive? Spacers, steel spacers to space something off of, something, a standoff. So I'm DIYing my own. Things were going smooth up until I started filming. There. Nut, 1/4 inch hole. Bunch of spacers in no time. Yeah, so this is the plate bolted down. Now it is used, so that's why we have these two pre-existing holes. We had a whole bunch of other cuts and bends in this thing, and this is what I was able to get out of it. Minus the 2 holes. That was fine. You can see how well my template here works, my little drill guide. Like that was a pretty smart move, I'd say. Like it works, looks like it works pretty well. The screws nearly drop right in, so a couple of holes I might be a couple of thou off, but for the most part, like I don't think you could measure and drill that by hand any better, Like really the accuracy there is more like a CNC mill accuracy, I'd say. I mean I'm very happy with how that came out. Alright, so I got my spacers. The gear is going to sit on top of the spacers, just like so. Yeah, see, like that hole, it's close. I could probably just ream it out a little bit, but most of them just go right in. So what I'm doing here, this is going to be the bottom of the thing. I'm adding in the stiffeners, strengthen up the base a little bit. Alright, I got the front little cross member support kind of where I want it, I think. Nice and squared in there. Which, I mean, it should have been squared anyway. Like, I probably didn't need to use these square things, just because if the base is square and all of the dimensions from the sides are the same, it should have been square, but at least I know it's going to hold it for me and, you know, not go anywhere. Okay, got a hole saw here. Reason being, we have a little step on our hydraulic motor, and that step is 2.5 inches, which conveniently the gear will fit right through, I think. Yeah, it will. So, 2.5 inch hole. It's a little bit undersized in 2.5 inch, so we should have a little bit of play there to adjust the tension on the chain. But hopefully my wooden gears, which should be completely accurate because I compared the two, well, that won't be an issue. So now I have the fun process of drilling a 2.5 inch hole through a 1/4 inch piece of steel with a hand drill. All right, hole was drilled. That was not fun, but it's done. I have a plate of steel made up to weld/install it right about there. I hope that'll give me some extra support for my bearing to support the machine, and also any side load or back and forth load for that matter. I think it'll help kind of distribute the load better. So yeah, I'm gonna weld this in, and that'll basically be it for the bottom. I got 2 holes I got to drill for the motor, 8 holes for the bearing, and paint it really. At least the bottom. I mean, obviously the top's got a lot to go, but the bottom, I think that'll be about it. Gotta grease this bearing. That's gonna be pretty easy, I think. Nope. I feel bad for whoever's got to grease this bearing later, because getting to it, not gonna be easy. Oh wait. That'd be me. Who are you kidding? I'm never greasing this thing again. After some minor debate, I've determined that I'm going to install the base onto the machine. Well, okay. After some debate, I've decided to install the base here onto the legs and then assemble the rest of the machine on top. It's going to get too heavy to move. It's going to get too awkward. And if I drop this on my finger, it's not going to sever anything versus if I add a couple hundred more pounds to it. So I figured now would be the time to do it. Not easy to do, entirely doable. Done it once when it was lighter, more flexible. Now it's a little more rigid but heavier. So, I don't know. We'll see how this goes. Well, it seems the extra weight didn't affect it at all. So that's a good sign. I've never used a bearing like this before, so I don't know if I trust it yet. But, I mean, heck, it seems like it's working. Okay, I'm ready to make the first cut on my sheet. This 2x4 sheet will become the base of the machine. Straight edge, 2 C-clamps and a grinder. That should do it. I will then drill the hole for the bearing. I really want to put this metal onto that bearing, see if it does anything or gives me any issues. So it's a nice little test. And then I got the hydraulic motor, it's on its way. I can then drill the hole where that's going to wind up and then kind of start fitting the rest of the machine together after that. Going to have a lot of cuts to do, but that's okay. Well, I got it cut. I'm using my drill guide here to tell me where to put the holes. I don't think I've shown it yet, but it's really came in handy when I got the bearing mounted on that lower plate. Actually, I think I didn't refill it. I think I just put the bearing there to see how it fit. But anyway, I think this little jig really is a great way to tell you where you need to drill. And unlike that 5/8 plate, this 1/4 inch only needs the center bearing mount. It doesn't need the outer ring or the gear mount. Whole lot less holes and a lot thinner material. So, you know, that's a plus. So straightness of the holes is important. Oops. Because if my drill's off, my holes are angled, my bearing's not going to want to fit. So the plan is to use the bearing as a drill guide when I drill out these holes to the final size, 1/4 inch. May not be too critical because I could just ream them out, but seems like a good idea, I guess. And because of my one bad hole, I'll move it to an existing hole. And tighten it down just a little bit, of course, just to hold it. So here's the bearing. If you notice, it's just bolts with little nuts for spacers. Because if you run a bolt head through this bottom here, it's just going to bottom out on here, so you need a way to space it out. I was looking on the examples online on how to install a slew bearing, and most of the time the workpiece has a machined, I don't know, let's call it a cutout for this bearing to sit in. Obviously I don't have that, so I got to make do with my bolt spacers, which will work fine, I think. Going to install it from underneath, and I have a lifting eye here that I'll use to actually pick this plate up for me. Looks a little small in there, doesn't it? Believe me, your concerns are shared. I don't know if this bearing's going to be big enough. Well, so far so good, I guess. The legs are holding up that little plate. Plate's spinning around pretty nicely. Well, I started the seat base, as you can see here. This little shelf I made was supposed to hold the hydraulic tank. And there is no way that that's going to happen. It's just not enough room in this little thing. The tank, as close as far as I can get it, the spout was like there, which is kind of right where your seat would be, you know, right here. The spout was like there, and everything was just so close. And then the edge of the tank would have been here, and then the exhaust from the engine was right next to it, right by the outlet. So I had to rethink it. I'm going to, I didn't want to do this, but weld in 4 corners and make the seat base actually the tank. I don't know if I can do water tight or welds yet, but I kind of have to now. So yeah, that's what I'm going to do now. I'm going to cut up what I did here and then remake it. Now I got to get some curves onto the back here just to make it look more professional, not homemade. So I'm going to use my CNC machine to cut out a little template here. That's kind of what it's going to do. Just waiting for the computer to boot. All right, here goes nothing. And I think that is the last cut that router bit will ever make. Anyway, what better to use than 1/4-inch walnut veneer with the stencil cut. I'll just fire up my little Vivor plasma cutter and have at it. Well, with the plate flipped over, I just come back and sand off all the slack. The weld-in bung holes have just arrived. Picked up a breather cap. The McMaster website. It was just black. Well, that's going to be ugly. So I'm glad it's not. It's not too bad looking for, you know, $3 or whatever it was. Yeah, and it breathes. All right, cool. But the important part of these guys, kind of what I was waiting for. Little weld-in flanges. So one's going to go about there for the hydraulic filter cap. 1 1/4. It's going to go somewhere below that. Weld that bad boy in there. It's supposed to be steel, but this looks like, I don't know, malleable iron or whatever. So that's going to be interesting to weld, but we'll see how it goes. But yeah, so that's where I am. Gotta drill some huge holes in some thick metal. Always fun. All right, my seat tank is done. I gotta pressure test it still. I don't know if my welds are air watertight yet, but I put some pipe plugs in when I welded it just to make sure that this didn't deform or anything. I'll show you the inside. Not much to it. Let's go over here to the back. We got 2 vents, and underneath 1 1/4 feed where a huge barb goes. And yeah, I'm pretty happy with it. Weighs a ton though, let me tell you. So now with the back done, now I'm starting on the front. This is going to be, what holds the boom. Well, I measured between the 2 pins. We had 5.5 inches. I'm guessing there's some kind of geometry that goes on when they make these little mini diggers, and I don't want to mess with the geometry. So the pins are in the same position, only moved in a little bit more, give me a little more meat here. They were using 10mm plate probably. I'm using 1/4 inch, so this is going to be a little weaker, but we'll see how it goes. So yeah, I got these 1/4 inch holes drilled where they need to go. Since these both need to be identical to line up, I have them clamped together. I'm going to put 2 1/4 inch holes here and then drill the 1 inch hole for the actual hydraulic pin. This representing the floor that it's going to sit on. These are pushed back up against it just to make sure they hopefully stay in their same spot. So with them clamped together, I can use the top as a drill guide for the bottom. Make sure our holes go in the exact same spot. Now, straightness is a concern. Like these holes, I can guarantee you that my drill bit wasn't, not parallel, but wasn't 90 degrees, I guess you could say, to the hole. I'm guaranteeing you it's that way. Don't know how much, doesn't really matter. What matters is the 1 inch hole goes straight into that metal. So I've been using drill guides this whole time, and nothing's going to change now. The gear I purchased has a 1 inch inner diameter. Nice good steel plate, nice and flat. Very good chance that is nice and centered. So I'm going to use that as a drill guide to drill the 1 inch hole. So that is where that goes. Line it up and clamp it down. Now, chip evacuation, I think the word is never going to happen with that plate clamped down. Chips are going to gum up and cause a problem. So I have a manual excavator here. One of those every now and then. And cooling is another slight concern, to not dull the bit with the number of holes I have to make. So I have an auto oiler. So I have a manual oiler, sorry. Now with that said, and with the manual air, I also have a manual oiler. So, let's dig in. Might as well put some oil in there now, huh? Ain't gonna hurt nothing. And let's see how well this works. Smoking means the oil's cutting. Chips everywhere already. Perfect, perfect. A little more oil. that is all there is to it. And we can do a fitment check real quick if we'd like. Ooh, that's a nice hole. So, yeah, that takes, I mean, not forever, but it's not exactly quick. I mean, it is when you consider it's a 1-inch hole. But, you know, when you're working with hand tools, I don't think you're going to get any better than that. So I just got to do that 3 more times, at least for this, and then probably start working on the boom. Made some upgrades to my drill jig. This is version 2, a little heavier duty. If you remember, I made one for the legs of the machine here. And this one is for the boom. I need, what, 4, 5, 6? 4. 4 holes. Well, 2 on each side, but yeah. So 4 different uses for this one, and the little one I didn't think was going to last too much longer. So that's why we have this one. I think if I ever make another YouTube channel, probably going to call it, like, I don't know, Jigs and Drill Guides. Works pretty well. Which isn't really a bad idea. I mean, most people that do things, watch things on the YouTubes on how to do things, aren't, you know, seasoned machinists. They're just people that want to do a project, may not have everything they need. I surely don't. So I don't know. Maybe this will act as some kind of guidance. You know. Should have drilled that down a little better. That's good enough. So I drill until chips start falling and pull out, because that means I got my starting point. Little hole and a little hole on the other side. Now I just, you know, make them bigger. That's pretty good, I'd say. Yeah, I don't know, I'm no expert, but that feels pretty good. I suppose for real tests, get those plates nearly touching. Now lift the boom, and if they move or try to wobble themselves wider, then I know I'm off somewhere. Oh, that's nice. This thing might actually work. All right, this I just cut out, did my measuring, whatnot, cut it out with the grinder. I need to make a second plate. This is going to be where the hydraulics mount to the boom, at least the lower half of the boom. We'll have a hydraulic down here and then one up here. So just got to cut that out real quick. Well, this is one of the last 2 cuts I need to make. As you can see, my welding bench, not really much left of it. But that's okay. So this is going to be the plate for the outer boom that I don't know what it'd be called, but that's what I'm going to call it. Because you got the main boom, maybe it's called the jib. I don't know. I'm no expert. I'm just building it. Alright, let's do this. Alright, perfect. A little bit of burn there, not too bad. No real fires to put out this time. So successful cut. So I'll unbolt my plate and make another one. Alright, plate number 2 is ready. With how nicely the last one went, I expect this one to fail miserably. But we will see. Anyway, now the plates are mated together. Now I can come back with a grinder and clean up all of these marks left from the plasma cutter. It's pretty ugly on this one, I know, but it's workable. Better than grinding the whole thing out. Okay, back to my tank here. I plugged all the holes with some of these, I don't know, pipe plugs. This one drilled a hole in, ran a 3/8/16 tap down it so that I could thread in my pressure tester, which I have hooked up here. Now pumping this would take 2 years because of the volume of air. So, popped off the bleed screw. Gonna use the compressor to get it going and hope I can get that screw in there in time and see if this thing's gonna hold pressure. Well, it's my first time trying to make anything liquid or airtight. So I would say so far I'm not that bad. I took my sweet time making this, trying to make the welds as clean as I could. They're not bad, like this one. You know, that's pretty nice. You know, the same with this side. The seat here, yeah, it could be a little better. The bungs, yeah, those could be better. But for the most part, the only place I'm leaking are the bottom corners. So if I did fill this thing with water, or fluid, I wouldn't do it with water, rust too quick. You know, flash rust. But anyway, the corners are pretty much the only place I'm really leaking. So I'm gonna seal those up the best I can, but like I said, even if they are leaking, it's not like it's ever actually gonna leak, because there's just a pinhole here and there in the corners. But anyway, it shouldn't be that hard to fill them up. Well, some cutting, grinding, welding, testing, pressurizing, welding, cutting, grinding, you name it later, and some color. And this is my seat tank. Pull the pipe plugs out, of course, later. Just all the fittings that should be in here. But yeah, that part is done, so that's good, because it's a lot. Let me tell you, getting it on this trash can to paint it was not easy. That thing is heavy. I had my dad whip me up a mockup hydraulic, and then I took some sawing and cutting to it when I found the actual dimensions of the hydraulic. So this is my mockup hydraulic. I don't have the actual ones yet. And turns out I needed to adjust the slower pin, which means I had to take off these plates, plug the hole that used to be there, locate and re-drill my new pin. My alignment is still quite good on both. So, happy with it. Now have the controller plate built and mounted, That's going to be where the valves go. Underneath is where the, I think, feed hoses are going to run. We'll see if they fit. Got a half arch cut in the bottom of it, so I'm just going to tack this on real quick. Probably call it a day. Okay, I got my controller plate installed. I have some pins in to the boom. I have my first wooden hydraulic. I have my file hooked up to my other wooden hydraulic, and I'm coming over here to mock up the bucket hydraulic. This would probably be easier to see if I didn't have all this junk in the background. But I basically got my support plates here that's going to support the front arm and the 3 pins. So the pin for the boom, pin for the hydraulic, and then this is the pin for the other hydraulic. And the hydraulics I'm getting are 15.5 inches long from pin to pin with an 8-inch stroke. So I'm at 15.5 inches here. Putting my bucket like so, which isn't bad. I don't know if that's a good dumping spot. I think I prefer it to be a little bit higher, like about there. Maybe I'll adjust it a little bit. All right, I've decided that is where it's going. So yeah, took an hour and some change to get to that point. Anyway, kind of a long time, but I think that that'll be happy with. All right, so that's where it's going to be. So now I just got to transfer this into steel and build it. Too much time and effort has led me to this point. I have my dummy hydraulic hooked up to the end of the bucket boom, and I'm seeing how well it works. And it looks like it's going to work fine. I need to determine the length of how long this is going to wind up being, and then it's really the final stages of painting and assembling and final welding and making sure everything is straight. But that's working pretty well so far, I'd say. That's a lot of holes to drill. It feels like I've been drilling holes for days. Alright, I got the body pretty much done. I got some holes drilled for a motor and a hole for the oil drain if I ever want to drain the oil. There's the motor hole that's going to hook up to the chain. I added these little sporting brackets just to make sure I didn't have any issues. Welds are all kind of cleaned up. Bladder's all gone. So now it's just start painting, I suppose. Alright, we got some color now. I think it's looking pretty good. Gonna mount the motor. Oh, by the way, I installed the hydraulic motor. I installed the chain that hooks up to the gear under the base here. That was a nightmare. Sizing up that chain, it was not fun. And then getting the motor in, my hole was a little off, so that sucked. If I push the motor forward a little bit, chain way too loose. Pulled it back a little bit tighter, but it needed to go back more than my hole was. So I removed another link from the chain, and that just made it way too small. It was just the absolute worst spot in the world to put that. I picked up these little rubber blocks. Got them on the old Amazon. They're just little neoprene, I think. Rubber blocks. Put them down here where the motor's going to mount. I just ran over to a local hardware store to pick up some washers. I'll show you the mounting plan real quick like. So I'm going to have the engine sitting on top of the rubber washer with this little fender washer. And then this is going to be the steel plate. I'm going to put another one underneath with another fender washer. That'll give me a little bit of engine isolation / dampening, and everything will bolt together. So that's the plan. Should work. Engine is a Honda 5.5 horsepower GX 160. If you know anything about engines, you're probably looking at this saying that is underpowered. You should have got something larger. Yeah, well, that's what I had. And actually, this isn't even my engine. This is on loan for me, for my buddy Jack. He bought it because he needed the gas tank for a welder he had, and he didn't know you could just buy the gas tank, so he picked up this whole motor. I was looking at it in his yard one day because it's been sitting there for months. Oh, hey, Jack, what are you doing with that engine? I need one for my little mini bike frame you gave me. He's like, oh no, I need the gas tank off that. You can't have it. I was like, well, what if I just buy a new gas tank? You know, Honda gas tank. Can I have it? Yeah. Okay. So I put the engine in the loader bucket, had him drive it over there for me, and it got kind of destroyed here and here because he forgot it was in the loader bucket. Lifted the loader bucket up to turn around and dump. So you lift the loader bucket up, kind of like that, to get into tight corners, and out the engine came, 10 feet in the air. It was pretty funny. It didn't hurt it at all, other than, the dents and whatnot. But anyway, so, I went to go order him a gas tank. He's like, no, just wait. I'll let you know when I need one. And this is where we are. Part of me thinks he thought to himself when I went to buy the tank, he's like, I'm never going to use this stupid thing. Don't waste your money, Brandon. It's kind of what I think happened. So anyway, that's how this motor came to be here. Working on mounting the control valve now. Now, when I started thinking I wanted to do this project, I knew this was going to be really expensive, but what's nice about, well, I don't know, nice, but between Thanksgiving and Christmas, nobody buys parts they don't need. So random things don't really sell. So if you're going to try to lowball a seller on eBay, I find that is the ideal time between Thanksgiving and Christmas because their sales just plummet. That's what I did here. This bad boy retails for, I don't know, depending on where you get it, between $180 and $600. I got this thing delivered for less than $100. So this was the first part I bought for this thing. I wanted to get that squared away. Now, I'm only going to be using these outer two. I put some plugs in the middle valves. It's a 6-way valve. Yeah, 6-way valve. But I don't have tracks. Don't need these. Probably not going to add a thumb. So it's got plugs, and I probably won't put the sticks in there. It just won't do anything. But I got it centered, I think. Just tightening it down now. And hopefully I don't have to take it off ever again because this thing is heavy. Now we got these fancy rubber boots that I guess go on here that I probably should have put on first. Alright, turns out these go on first. Then the boots go on. Yeah, I can't get that side on for the life of me. Probably have to take this valve off again, which I don't want to. I'll keep fighting with it. Caps on the top. And we have valves. A little small, but Perfect for my little machine. All right, it's been a little while since I've done any filming of this thing. When you need to order something from surplus, it takes a week, and then you forget your order, and then forget some of the stuff you needed, so you place another order. Paying more shipping, of course, takes another week. I've had about 2 weeks of downtime here. Really sucks, because once you get going on a project, you really just want to keep going on a project. But parts came in today, the final parts to hook up all the hydraulics. So it's a mess, but all of the hydraulics are probably hooked up. I should have about a 5-gallon capacity in my tank here. I don't know what the hydraulic system is going to use. Maybe a gallon or so. So I might have to go get some more, but I picked up a gallon of fluid. This is the only place local to me sells it is AutoZone. And they sell this RO, which I guess is some kind of anti-rust version of it. I don't know if it's going to be any good, but we'll see how that goes. All right, I have a funnel to NPT adapter there. So let's get some of this stuff in there and see what happens. Well, now I use for my engine to start. Don't quite remember how this works. So that's on, fuel on. Fuel might have already been on. No, it's on now. All right, let's see what happens. Yeah, I don't know what I'm doing. Oh, this sucks. Wait, what's this? All right, that's the throttle. Well, I definitely smell gas. Choke off, fuel still on. A little bit of throttle, I guess. I definitely need choke. No leaks everywhere, so I think we're going to be okay. This should be boom up. Let's see what happens. Oh, look at that. Now I can get my ladder out of there. Try the stick out. Yeah, that's pretty scary. So yeah, where we are is the boom up and down is way too fast. It's putting too much flex on the machine back here. If I do that enough, I guarantee it will break. Hopefully you see, I should be able to move that. So I think it's a problem with it not being bled. Like there's still air in the system. And I think once that's out, it's probably going to operate as smoothly as the rest. Because the stick out in the bucket, they're fine. It's just that boom up that's not good. I'm going to start it back up again, test the rotate of it. Hose leak out on me. We gotta fix that. Alright, leaky hose has been repaired, and by repaired I mean I tightened the fitting. It's pretty easy to do. So I'm gonna see if it rotates now. All right, so final thoughts. Does it work and can it dig holes? Absolutely. The problem is there's a lot of them. Well, first and foremost, I am glad I didn't buy that Harbor Freight digging machine because moving this thing around without tracks sucks. I don't think I ever would have been happy with that thing and probably would have regretted my purchase the whole time. With that said, this machine wasn't exactly cheap either. I probably have a little less than $800 in metal. I don't have anywhere near $800 in metal. What am I talking about? The 1/4-inch material was $300, and then everything else I bought was like less than $200. So let's say $500 in metal. The hydraulics were the expensive part. I probably have about $1,200 in hydraulics. Most of that was error spending, like fittings that I didn't need, and then having to buy additional things that I really needed and had to pay more shipping. Hydraulics was a definite learning curve. I way overspent on the hydraulics because I didn't know what I was doing. I'm perfectly fine with that. All right, there's a lot to unpack with this thing. So first, I would say I'm a better welder now than I was when I started this thing. Far superior. My welds, obviously they held up. It didn't fall apart first try. The welds aren't too bad looking. I think I did a pretty good job. I've never made anything liquid tight, which this tank can do. I'm getting pretty good at welding. I now understand slew bearings, turntable bearings, hydraulics, flow rates, cushion valves, pressure relief valve. I learned quite a bit about hydraulics. Like even spool valves. I know the differences in different types of spool valves and when you would use them for what. So I would say that the cost and time that went into this thing for experience may have been worth it. Now, time. I started gathering stuff in November. I wasn't just going to take a huge old chunk of money out of the bank account and pour it into this thing. It was piecemealed all the parts together until I was ready to go. I started working on it late January, and here it is March, and it's done. But there's been 2 weeks of just sitting around waiting for parts to show up too. I don't think I have that much time into this thing. I do. I really do. I would say I have probably a month into it. That being Monday through Friday, a couple hours a day for a month. That's overall, I wouldn't want to say happy with the performance because I'm sad I don't think it's going to last much longer. Well, first, let's talk more about the actual build of it. You got to understand the tolerances that go into this. Like, I needed straight pins into that metal. I had a lot of holes that needed to be drilled. They need to be straight, and they need to be accurate. When you're talking machining, there's tolerances here. I think using that laser cutter to build all those templates was a phenomenal idea because it gave me that accuracy I needed. Get that slew bearing centered on there, along with the gear. You're talking crucial measurements there, and it worked. The same with the wheel axles and all of the pins on this machine. All of those needed, they had tolerances to them. If it was too far out, you'd have a nightmare in your hands. Using that laser cutter to make the templates for the holes, I think was a genius idea, and obviously it worked. Having that plasma cutter allowed me to make all of these fancy cuts without, spending 3 weeks of grinding, which I did a lot of grinding, clean up the cuts, but not to actually make the cuts. So that was a phenomenally handy tool to have. Could have done it with a grinder. I could have eliminated the round cuts and used a grinder, but the plasma cutter really came in handy on that one. So let's talk problems. The stick cylinder, I think that's what that's called, that last arm, and the bucket cylinder. You can operate those nice and smoothly. The problem is this boom cylinder. I don't know why this is. I'm no expert here. That boom cylinder, there is no nice up and down with it. It's either just fly up or just slam and hit the ground incredibly fast. That is a problem. Like, I think it's this thing's downfall. Because I think it destroyed the bearing. I didn't have this much play in the bearing as I do now. Now, to give that bearing credit, I don't think it was designed to have that impact that that boom dropping or lifting gave it. And it still didn't fail. Now, if I was on this thing when it failed, well, I don't want to be on this thing when it fails. That's why I didn't put a seat on it, because I didn't want that seat to get in my way in case I had to bail off of it. I think that bearing is destroyed now, and I think it is this cylinder / boom's fault. I don't know why. I don't know why I can operate the bucket and the stick smoothly and slowly, but I can't the actual boom here, the boom lifting and down. I thought it was originally maybe I had air in the system. So I wanted to dig my hole to get this thing down as far as it can go and go up and down a couple times, get the air out of it. But it didn't get much better. However, when using two at the same time, obviously the little motor doesn't have the power to move them both, and the pump doesn't have the flow to move. Well, it might have the flow, I don't know. That's the only point it would actually function the way you would expect it to. Overall, I would say it was a good first attempt. Now, attempt number 2, since I know more about it and have all these parts now, will be much better, I think. I have it's a 2-stage pump. It's 3/11, so at high pressure it's 11 gallons a minute, low pressure it's 3 gallons a minute. I don't know if when I'm pulling 2 levers, if the pump gets down, starts doing the 3 gallons a minute, and that's why the boom suddenly starts working a little better. If that makes sense. So yeah, I don't know which one's working out, because it's never felt like the pump is stepped down into its lower flow. It seems like it's always been the same. So I don't know if I'm not using it enough for it to kick down, or if it's always been down. I think I have too much flow coming out of that motor for this kind of a lightweight machine. I think if I wanted to do anything else, I'm going to ditch that hydraulic motor and get probably the smallest one I can find, and then try this again. I can replace the bearing. I found a suitable replacement for not too much more than I paid for this one, but I don't know if it's worth it. I think the slewing that I wanted was kind of a dumb idea. It makes sense to me because, you dig a hole, you then, a trench, really. You can then put the machine next to the trench, slew out, and then drag the dirt back into the trench. I don't know, it just seemed better to me, more maneuverable. So, after you fill the hole, you then rotate back, drag yourself forward, rotate more, pull the hole back in. It seems like a better way to do things, having that ability to slew. But I now realize why many digging machines do not slew. It is a dumb idea. You're going to have so much money into a slewing bearing that's going to be able to support those forces, those impacts that this machine is going to produce, and it's not worth it. Just rotate the boom over, do what you need to do. I think some modifications are going to be needed. It dug a hole, and I'm happy with it. But this whole time I had that in my mind that bearing may fail, and it probably did. I don't know if it actually did. It's still working. Hasn't failed yet, but I don't want to be on it when it does. So, plan B. I guess we're at plan, I don't know, what, W by now? Moving it around on these legs, again, that sucks. It's not fun to do. It takes forever. You're better off dragging it over there somehow and then do your digging once the machine's on spot than trying to drag the machine really by itself all the way over to wherever it is you're going to dig. Tracks, those are what this thing needs. It needs a swing type boom and tracks. If it had those two things, the life would be golden. So, my valve here, it has these 2 ports. Perfect for 2 tracks. The machine can be lifted from the base. The front can be cut off. Additional supports added here. Machine fixed to the base. And then a swing boom added with hydraulic cylinder underneath. The problem with that is, well, money. I've got $100 and some change in the hydraulic motor and then another $100 into the cushion valve. and the cushion valve can stay, the motor would have to go. So I basically wasted the money on the hydraulic motor, and now I got to spend more money on another hydraulic cylinder, and I'm almost out of metal. I don't have enough metal to make another swing boom or add legs. So another half a sheet of 1/4 inch material, another hydraulic cylinder, and some more 3-inch box tubing. And I can make this thing into a swing boom, which would probably be a better idea. However, I still don't know what's up with that cylinder. I really think there's air in it, because I can lift this up right now and I can feel a little bit of a damper. I think there's air in that cylinder. I think I just need to go up and down a few times. I think this whole time I've been thinking to bleed that hydraulic, I just need to bring it up and down a couple of times, which is what I did for the other ones. They seem fine. Do they? Let me check. Yeah, you're not moving the bucket or the stick. I don't care how strong you are. But the boom, I can just pick that up all I want. It dawned on me, I don't need to dig a big hole. I can just pop that pin out, let the hydraulic fall, and then run the cylinder in and out. That'll probably take care of the bouncing. I'm going to take, if that fixes my bouncing up and down problem, I'm going to replace that bearing and then use the machine as I see fit until it breaks or I build something better. I think that's the plan for now. We're over an hour and 20 minutes into this video. I think you guys get the gist of it. So let me know what you think of it, any improvements I can make. And to Jack, you've known I wanted to make myself a little mini digging machine for many, many years now, and well, I finally did it. And your motor does run, so I appreciate it. Thank you. Everybody else, thanks for watching.